Let's have a look at how to multiply polynomials. The first and simplest type of polynomial we often need to multiply is a monomial multiplied by a monomial. In such a case, you start by multiplying the coefficients, and then you write down the common bases and add their exponents using the multiplication rule. Let's say, for example, we have 3x squared times 2x cubed times y. The coefficients here are 3 and 2. So we can multiply these numbers. The x squared and x cubed terms have a common base, which is x, and if we add up their exponents, we get 2 plus 3. All we did here was use the multiplication rule for exponents. Next we have the times y at the end. If you have difficulty understanding what was done with the y, you could think of 3x squared as having a y to the power 0 which isn't shown. Because y to the power 0 is equal to 1, so the final y can be thought of as coming from the multiplication rule. If y to the power 0 was multiplied by y to the power 1, the common base would be y, and the exponent would be 0 plus 1, which is equal to y to the power 1, and that simplifies to just y. That explains how we got the y in this expression. So the final answer then becomes 6x to the power 5 times y. In summary, to multiply a monomial times a monomial, start by multiplying the coefficients, then write down the common bases and add their exponents or powers. Let's take a look at another example, such as 2x times y. To simplify this expression, we can multiply the coefficients. 2 times 2, which is equal to 4 in this case. Then we multiply x and y, which ends up giving us 4xy. The next type of polynomials we may need to multiply would be a monomial times a binomial. To do that, we would need to use the distributive property and multiply all the terms of the binomial by the monomial. So for instance, if we had 2x times 4x squared plus x, we simply need to use the distributive principle and multiply all the terms in the brackets by 2x. First we need to multiply the 4x squared term by 2x, then we need to multiply the x term by 2x. The first term would give us 8x cubed, and the second term would give us 2x squared. In summary, to multiply a monomial by a binomial, use the distributive property, then multiply each term in the brackets by the monomial in front of the brackets. So what about multiplying a monomial by a trinomial? Well, that's exactly the same as the previous case. So we just have to multiply all the terms in the brackets by the monomial in front of the bracket. So if we have 3x times, in brackets, x squared plus 3x minus 5, we need to multiply all the terms in the brackets by 3x. The first term then becomes 3x times 2x squared. The second term then becomes 3x times 3x. The last term then becomes 3x times 5. This simplifies to 3x cubed as the first term The second term then becomes 9x squared, and the final term simplifies to minus 15x. Again, the idea is the same. The distributive property is used to multiply each term in the brackets by the monomial outside the brackets. The next frequently occurring problem in multiplying polynomials is when we have to multiply a binomial times a binomial. In such a case, we have to distribute each term found in the first bracket into the second bracket. That is to say, the first term in the first bracket must be multiplied by each of the terms in the second bracket, and the second term in the first bracket also needs to be multiplied by each of the terms in the second bracket. For instance, if we had 2x plus 2 multiplied by 4x plus 3. If we were to multiply each term in the first bracket by both the terms in the second bracket, we would first have to multiply 2x times 4x. Then we would multiply 2x times 3. That would take care of the first term. And we can move on to the second term, which is 2 in this case. We start by multiplying 2 times 4x, and then we need to multiply 2 times 3. So we are left with 8x squared plus 6x plus 8x plus 6. Now we have to recognize that this is simply a polynomial, and we can simply use what we've learned in the video about adding polynomials. So we can start by looking for like terms and adding them up. 6x and 8x are clearly like terms, and when we add them we get 14x. Since there are no other like terms to take into consideration, the polynomial simplifies to 8x squared plus 14x plus 6. When multiplying two binomials, some people use a method that is easy to remember called the FOIL method, where FOIL is simply an abbreviation, and in this abbreviation, F stands for first, O stands for outermost, I stands for innermost, and L stands for last. FOIL basically gives us the order in which we should multiply the terms in each of the binomials. Well, what does that mean actually? Let's take the binomials in the previous case and try to apply the FOIL method. We have 2x plus 2 times 4x plus 3. The first terms would be 2x in the first bracket and 4x in the second bracket. That takes care of the f in FOIL. If we multiply the first terms, we get 8x squared. Well, now for the O in FOIL, the outermost terms are 2x and 3, and if we multiply 2x times 3, we get 6x. The I in FOIL stands for innermost, and the innermost terms are 2 and 4x. Multiplying 2 times 4x gives us 8x, and the last terms are 2 and 3, and if we multiply 2 and 3, we get 6. Just like before, it's just a case of adding up a polynomial. The x squared term doesn't have like terms, so we simply have 8x squared. Well, 6x and 8x are like terms, and if we add these terms we get 14x, and finally 6 is the only constant, so the final term is 6. That is how the FOIL method works. Notice we got to the same answer, as we did when we used the distributive method. And that's all we have for today on how to multiply polynomials. The best way to support this channel is to subscribe, so we kindly ask that you please subscribe and help us in our vision of covering more subjects in mathematics, and we'd also like to cover some stuff in physics and engineering in future. Thank you, and please subscribe.